The broadcast is now starting. All attendees are in listen-only mode.
Welcome, everyone, and thank you for joining us today. My name is Kara, and I'm with the LTAP Center here at ODOT, and I'll be your host for this webinar. Today's webinar is Traffic Monitoring Part 1, Where does ODOT get traffic count data? And we're thrilled to have Sandy Mapel as the presenter. Before we begin, I'd like to cover a few housekeeping items to ensure a smooth webinar experience for everyone. If you have any questions during the presentation, please use the questions panel on your screen. You can type your questions there and we'll address them during the Q&A session at the end. If you're experiencing any technical difficulties or have any other issues, feel free to use the chat panel to communicate with our team and we'll do our best to assist you. Please note that this webinar is being recorded and the recording will be made available to all registered attendees after the session. All right, with that out of the way, let's get started. It's my pleasure to hand it over to Sandy Mapel. Sandy, the virtual floor is yours.
Thanks, Kara, and welcome to ODOT Traffic Count Session 1 to show people a little bit about where we get our traffic count data. And I'll also let you know that there is a part 2 as well, and it delves into actually accessing the data. So welcome, and let's get started. And I'm hoping you share the correct, I'm seeing the correct screen. So today we want to go a little bit over a few items. We're going to talk about our traffic monitoring program kind of in some general terms, what we are and what we aren't. Then I'll go through our short-term count program, our permanent count program, what kind of data we collect in those. One of the biggest things I want to share with everybody is how our count equipment actually operates and some of the pros, cons, strengths, weaknesses kinds of things of using different equipment and those considerations for using that different kind of equipment so you know what you're getting when you see our data. The other item is I'll give you a little bit of a background on some considerations if you happen to be a person that's developing construction plans. So for starters, one of the things that I want people to know is what we aren't, which sometimes can be a little bit confusing. So we are not traffic operations. We are not the folks that operate the signals. We're not the folks that maintain the big overhead ITS boards, the ramp meters, all those types of things. Those are more on what I call the traffic operations side, but we are really good friends with those folks, and we use a lot of the same types of devices in the actual field out there, but they are not necessarily set up or calibrated the same. So from an operation standpoint, they need the information right away. You couldn't wait a day to determine, to send the signal to turn on a ramp meter or to adjust the timing on a signal. So their need is operational, and their operational need is a much more immediate need, as opposed to the traffic monitoring side of, the traffic industry. And ours is more of a data quality issue. So they have an immediate need for data, but we need more of a 95% or better accuracy. So that's important to understand. They're both very important. They're just different facets in the traffic arena. One of the other things that we are not is we are not probe data in traffic monitoring. We are not streetlight data. Probe data is amazing for patterns. One of the big caveats I want people to know is do not use it for actual numbers. We were part of a big pooled fund study. So you may see, if you look at some of our permanent count stations and then you turn and you look at streetlight data, and you'll be like, well, these are great, they're so close. Well, they used a lot of our permanent count stations as calibration stations. So of course, if they were using that as their calibration point, they set those to be the same. So don't be fooled by that. That was very much part of a big pooled fund study. That probe data from streetlight and things like that are absolutely wonderful for patterns. But don't be fooled. Don't think that their AADT estimates are accurate. They're anywhere from 20 to 40% off. But what we are is we are traffic count data, and we pretty much are. Our data is used by everybody. This is my little sunshine. I like to put a little ray of sunshine. I mean, it gets used by all kinds of everybody. I like to say that there's pretty much everybody at ODOT uses it, from finance for predictions on revenue, obviously our operations and maintenance people, environmental studies, permitted lane closure, speed zones, everything. We have a little sliver of everything that goes on. So I've told you a little bit about who we are not. So let me tell you also a little bit about who we are and what we actually do and the data that we have available to folks. So what we really do is, quite simply, we count cars and trucks, and we count them by 13 different classifications. We'll get into that a little bit. So if you hear me say the word class, it means classification. We also have about 30 weigh in motion sites. We can actually weigh each axle of trucks at highway speeds within 0.5% typically. We only have to be within 5%. Usually we're between 0.5% and 1%. We're pretty picky about where we select our installs for those locations, which helps us keep our accuracy really well. We also collect speeds. Whenever you see a traffic count, a lot of our traffic count collection devices also collect speeds. And we'll get into which ones provide the best accuracy and which ones don't. We also collect data. We're a warehouse for data on bikes and peds. I'll concentrate today on motorized data. We're trying to become a leader in the warehouse for bike and ped data as well. And all of the data that we put into our data warehouse that we make available publicly, it is all reviewed, it's QC'd, there's notes, there's info, other details behind it. And then we also develop a lot of summarized reports and things like that for everyone else to use as well. So in general, we think of our world kind of in 3 components. We do 7,000 to 10,000 short-term count locations. Those are 24 to 48 hour counts. We do 7,000 to 10,000 of those a year. And then we also have anywhere, generally about 250, but we have around 300 locations. They're not all in operation at the, they're not all able to be in operation at the same time. So we have 300 locations, but somewhere around 250 of them are typically running. And those run 24/7, 365. And then we think of our third area is the management of all of that data, of those short-term counts and those permanent counts. And that's mostly more a part of part 2 of this series, but that is a cloud-based system. We do have multiple modules, and that's where you can access all of our count data. So where do we actually collect traffic count data? So let's start with our short-term count program. We have several different groups of counts, rotations of counts. We count every county in the state every 3 years. We count the state system in those counties, each of those rotations. So every 3rd year we count the entire state system, all the ramps, and we do some HPMS samples, which is kind of a federal, if you're not familiar with HPMS, it's a federal reporting, and those are literally truly samples scattered across. We also collect about 13,000 local road counts. We scatter those across a 6-year cycle. So if we're in a county every 3 years, we're counting roughly half of them every 3 years. So we kind of split those up. And those are kind of overarching. We do some so that we've got some counts for our safety office. We do some for modeling, some to just provide some more over coverage. So we do actually have a lot of counts on local roads as well. Then we also do a batch of counts on a 10-year cycle on a 3-year rotation. So we do, it's not the year 1993, it's 1,993 counts, so roughly 2,000 counts every 10 years. And then we also do special requests for projects, for studies, for other things like that. So this is our short-term count program. This is a sample of, you know, a group of counties that we are counting in one specific year. We've tried to balance these counties so we get a good kind of cross section of what the state would look like. You know, we have a mix of counts. We're kind of geographically and urban rural balanced every year. This gives you an idea of how many counts we have across the state. Every one of these little blue squares is a count in our database. So we have roughly 30,000 counts that we count on a fairly regular basis. So how do we count those? Everyone always in the road, and sometimes people ask me, why in the world do you still count counts that way with tube count? They are very accurate if you use the right kind of equipment. We get these counts anywhere between $60 and $300 for a 24 to 48 hour count. We get those prices because we're giving a contractor, you know, if we're doing 7,000 to 10,000 of these in a year, we're giving them a significant chunk of counts. So we get a really good kind of bulk rate pricing on them. There are a few downfalls. Occasionally, knock on wood, you can get, these are frequently nailed down. You can get people with nails in their tires. If this is done properly and they're taped well, they're supposed to tape over the nails. It's actually pretty rare as long as they're installed properly. This is an interesting one in case people have never seen this. These tubes are figure 8. We call this a flip-flop or a figure 8 or a crisscross. The way these tubes work, it's a pneumatic hose. A car goes over it and pushes air to this counter. Some of the downfalls and things that you need to be aware of need to be kept clean. The air switches need to work well, and there is truly a difference in the type of counter you use. We test all of the different vendors. There are a few that we don't accept currently. There are other counters that we do accept, and it really has to do with how well the equipment accepts and balances out those air pulses coming through. But we don't only use tube counts. That's some pros and cons about the tube counts, but we also use cameras. Some pros and cons about the cameras. They're pretty accurate. Any camera system that's out there right now that claims to get volume can probably get volume counts really well. We've only found one camera system that gets us all 13 classifications that we've tested. We are going to be testing the new MyoVision system that is now claiming they can get 13 classifications. The Litron system does get us 13 classifications. That one we've approved for use for 13 class. Everybody's trying to get into this business, but it is a lot more expensive than tube counts. The benefit is you are not in the road, so it's much safer. We also use radar counts. Most of our folks use, when I say our folks, I mean our contractors that take a lot of our short-term counts for us. A lot of them use Wavetronics devices. They're strictly a radar device. They're pretty durable. These units are very durable. We have some of them that are out there on the permit side. They've been out there for 12 years, haven't had any problems with them. I've been told roughly 10 years is about the life cycle of these, but we've seen a lot go a lot longer than that. I will tell you, they're great for volume. I would not trust their classification, especially do not trust it in an urban environment, which is a lot of times where these are used because you don't want to be in the road with the tubes. But you're not in the road, and if you install them correctly at the right distances, you can get really accurate volume counts. We have about 70 of these set up permanently, and there's only 3 of them that we trust the classification data on. So when I talk about these classifications, and I say 13 classes, this is what I'm looking at, these 13 classes, anywhere from a motorcycle to what my sister jokingly calls a Piggly Wiggly Wiggly. You see a lot of these out west. You also see these on the turnpike. They're not as common on our interstate roadways. But we'll get into this a little bit more, how we break those down. So piezos work just like tubes. Remember that in your head. Cameras, of course, is that growing industry. This is typically how they frequently work. They identify a vehicle and then they identify what it is. This is a class 3, this is a class 2, on the roadway obviously, but lines in their system and they count them as they cross. Some of them identify them and track them. Hopefully this video pulls up. Maybe we have to move it. It's working on my other screen. So one of the work and follow all those items you need to consider. So this is actually they started working on this well. They're scattered as our short terms, obviously, because there's way less. For instance, we have none in Seneca County. So if you're from Seneca County, I'm sorry, we have none in Seneca County. Actually, this one in Wyandotte isn't running right now, so we actually have none in Wyandotte as well. But the goal of these is not so much to have county by county by county coverage. It's more to have a mix of urban, rural, and different functional class. And these are used predominantly to take those 24 or 48-hour counts that we got and convert them into an average annual daily traffic, which is the most commonly used reference number. These, we install them obviously brand new, and we'll talk a little bit about how they degrade over time. So we do have to do repairs and upgrades. We try to do about 30 of them a year. Internally here at ODOT and Tech Services, we handle our own construction oversight and inspection. And the reason for that is a lot of people are like, why don't you just have the districts do that? That'd be great. But it is kind of a very niche area. And in order to be qualified to install these, you have to have kind of specialized training and know what you're doing. And our contractors, we have 2 contractors, they're both from out of state. So it's pretty rare. It's just a very end. In order for us to have warranty on any of our installs from the manufacturer, they have to be certified in that installation process. So that's how that comes about a lot of times. So this is a typical, this is not the best station, but it is pretty typical of what you see out there. Our most common layout is a loop. Now loops are easy, they're not a big deal. Anyone could install these pretty well, but by golly, they better make them square and perpendicular or the data gets wonky. These straight lines here are called a piezo, and then another loop. This is a very typical in pavement layout, loop, piezo, loop. Like I said, we try to scatter these to represent different areas. We have some that are WIM locations, which are way in motion. We have some that are for a long-term pavement program to look at the long-term pavement, basically the vehicles on those. And then we do this because we have to report a lot of data for national statistics. So let's talk about how these actually work. How does a loop actually work? All it really is a magnetic field, and it says, oh, hey, there's something on me. So I'm a vehicle. That's all it is. There's loops in there create a magnetic field. The vehicle comes across there, it breaks that magnetic field, and it sends a signal to a controller and says, I have arrived. Okay, so let's see if I can get this to work. So pretend this is a loop in the road. Your inductance is just plain. Here comes a car. A car is there. It says, hey, I have arrived. Okay, the loop turns on. And then when it leaves the loop turns back off. So what does that tell us? Okay, so the car comes on, he's on there, and he leaves. And we know how long it took him to go. So he arrives, That's time 1. We know when he hits the next line. We also know how far apart those loops actually are. So that's how we know what the speed of this vehicle. So remember I said we frequently have a location that is loop, piezo, the straight stick, loop. So what does this piezo do? The piezo is much more accurate. It functions just like a road tube would because it is a straight line, a set spot in the roadway. So a car hits it. It's only an inch wide. It knows exactly where that is. So it's like, oh, okay, there's an axle. Oh, there's another axle. So it knows this vehicle is 2 axles. So remember, if we had that loop here, we don't want that. We have that loop here, then this piezo, then this loop. We knew exactly when this vehicle came into this array, this loop piezo loop array. We know when they came. Now we know exactly how many axles they have. So now we can tell how many, in that case, it was a car. It had 2 axles. We can tell it was a car. We know exactly how fast it was going. And so we can now classify that as a car. Sometimes things get a little wonky. And remember, this loop says, I am the vehicle. And then when you leave this whole array, it says the vehicle is left. So in our world, 1 plus 6 equals 9. I'm like, I don't think so. So if you look at a class 9 vehicle, your typical semi, this is a class 9, it's your regular 18-wheeler semi. When we start seeing, this is part of our QC, when we start seeing that our 6s are really high, which are this type of vehicle down here, this really cool cyan color vehicle, there are 6s on our roadway, but not that many really. There's a lot of class 9s. We have a lot of semi trucks on our roadways. And unless it's a really hot, beautiful day, we don't have a lot of class 1s. We don't have a lot of motorcycles. So part of our QC types of things we do, this is just an example. If we have a lot of high 1s and 6s, then we know that something's probably up. So here's what's happening. We're splitting a vehicle. We'll probably have a type 9, and it's taking these, look like these 3. So it's saying this is a 6, and it's taking the little back 2 axles, you know, the lesbian motorcycle. So we joke and say a 1 plus 6 equals a 9, which means something, some different things like that. We won't get into all that. That's total field staff stuff. I don't even know how to do it. And I've been doing this for a long time, but they do. And that's the important part. So that's some of the things where these piezos tell you exactly what you have, exactly where the axles are and when they cross. So tube counts, that's very accurate. This is just showing you this distance, so it must be a motorcycle. Or there were 4 axles, and they were spaced, the axles were spaced this far apart, so that's probably a passenger car with a 2-axle trailer. So this is how those things are broken down in order to get good data out of a tube count. And this is where if those tube counts are not installed correctly, or the owner that's being used doesn't know how to break this down well, or it gets extra bounces in the air hoses, you get bad data. But if it's done correctly, you can get great data every day of the week. Some of our permanent sites look, and a little bit about how their construction is. Back to that same picture, and I could tell you a lot of problems with this picture. Not with the picture, supposedly, but with some things that we could have done much better in this. But this is the traditional loop, piezo loop. Let's talk a little bit about the life cycle of this. So loops, like I said, they're pretty durable. They can last a long time. Piezos are installed with grout. We all know Ohio has freeze-thaw. The piezo might work great, but it gets damaged by freeze-thaw and the grout. It's usually the grout and the pavement around it that fails, and that's when we lose our piezo. So let's say we now have just a loop and a loop. Now we can still, remember that little loop diagram with the yellow race car running by? We can still tell how fast someone's going. You know, we can tell when they get to the loop and when they leave the loop, and we can tell about how long they are, but it's not as accurate as when we had this piezo in the middle telling us exactly the number of axles and where they crossed. So we still get really good volume data when these piezos die and we still have the loops. And we get reasonably good speed data, and we still report that speed data. You'll still find it in our cloud system. And now what we report, instead of reporting every detailed little 13 class, we lump them together into chunks as far as roughly how long they are. So you can still tell if they're little cars, single unit trucks, or really big trucks. But you can't tell every one of those little 13 classes. And this is what the inside of one of those cabinets looks like. It's nice and cleaned up in there too. I like to see them when they're clean like that, because beasties eat wires and then we have problems. And then we have splices, and splices are never good on the longevity of a system. This is a weigh in motion site. This is how it's laid out with a template. This is before we actually installed it. So this will be a piezo, a special kind of piezo. It's made of quartz. This is a cross section of what it looks like. These are our weigh in motion sensors that we have locations that we're within 80 pounds, people going 75, 80 miles an hour, obviously over the speed limit on the freeway, and we're that accurate. So this is the grout. This, again, the actual sensor works really well for a long time. It's the grout usually that the pavement will get a little crack in it, then we'll get a crack in the grout, and then we'll get a crack. So that's generally how we degrade these. So we'll still have a loop. We can still tell how many vehicles are coming across if the loop is working, but these sensors are the weigh in motion sensors. This is the inside of the cabinet. So I do have a few pictures of how these are actually installed. So this is this normal piezo, not the fancy expensive weigh in motion ones. This is a normal piezo, and this is part of the training that these folks go through from these specialized contractors. These piezos are made out of brass. You have to be very picky with them. You have to test them when they come off the back of a truck before you install them. You have to wipe them down with alcohol. You have to wipe your gloves down with alcohol. They have to be very, they're put on little plastic chairs with your gloves that have also been wiped down with alcohol. We protect the oils from coming into, even from touching so that's what the part of the purpose of putting this Gorilla Tape down. Then they're pushed down to a certain depth with a little gauge. So it's a very detailed kind of process, and our concern is if we use contractors that are not trained in this, we're not going to get accurate data. We won't even get the on-site readings. So they're tested coming off the truck, then they're tested when they're in the ground, then they're tested again after the grout is put in. So it's obviously a specialized grout that's then poured around these, and then they're ground off smooth. And then we peel the tape back. And so there should be just a very fine amount above it. So when we're looking at these installs, since we like to install these in new pavement so they last the longest, we like to install these either the same construction season if it's an early construction project, an early pavement project, or we install them the following spring. And I am cognizant of the fact that it drives the public crazy, that they think this brand new pavement was out there, and then what's this, ODOT just finished up, opened this road, and now they're back here closing lanes again and installing these. We understand that, but you can't install this grout in brand spanking new asphalt. You have to wait 60 to 90 days because of the oils in the asphalt will also speed up the degradation of that grout, and the grout is the difficult portion. We could install the loops with a construction session, but they really need to be, we take extra care. You can see the corner of this loop. We take extra care to make sure that they are very perpendicular. We have a few sites that some districts have put in plans for us before, and we really have to, it's tough to get good data off of some of those because the loops were crooked. So we do like to know when these projects are coming up when you mill out ours. So we have developed a specialized note. You can find it in the TEM, the Traffic Engineering Manual. I know a lot of folks don't always look in there, especially if they're working on a pavement project. So I want to make you aware of the fact that there is a note in the TEM. There is some designer guidance. There is a plan note that's set up in there. There's also some designer guidance also in the TEM for us to be added to the utility list. Almost every project has a utility list. Include traffic monitoring tech services on your utility list. If you're doing a traditional mill and fill, pavement resurfacing project only, this is what the note looks like. It's pretty straightforward. But if you're doing a reconstruction, a major rehab, a new construction, anything larger than just a regular mill and fill, we really, really want to coordinate with you ahead of time, because we may want to have some underground pole boxes and conduits installed, while our specialized contractors are experts at the loops and the piezos and the wiring and the testing and all of those things. They do an okay job at underground work and what I call the dirt work. They're not bad at it, but I will say that there are lots of other contractors that are much better at it, especially the kinds of contractors and experts and operators that you find on those major rehab types of projects. So I will do a little shout out to District 6. They actually have a line item in their scope form. We're item 55 in their scope form. I know exactly where to look on their pavement projects. And it works really well. A lot of times we're like, yep, just mill it up, not a problem. But when there's a more major project, we like to be included. We have developed some standards. We worked with a couple districts and have done some things. Do not look at this. I should put a big red X on this. We are changing this. This attempt did not work well. We need to find a way to get through concrete barrier. Otherwise, we have to shut down and do a full one direction closure on the interstate or major roadways to be able to cut across. Not something we want to do. So we're trying to find a way to get through these concrete barriers. We're currently working with District 4, and we've got some good things in place. We've also gone over to Indiana and looked at what they've done. They've got some very small pole boxes that are like almost like the size of a water valve. And we've also talked to the pavement folks. So that's what we're starting to try in a District 4 project. So if some of this underground work can be included when these concrete barriers go in place, then an underground conduits, 3-inch conduits that go over to pole boxes, then we'll be able to come in and cut our loops and piezos and have a really well run system. We are moving towards cameras. We know that's the future, but not sure we'll ever be able to do weigh in motion off of cameras. So we continue to test lots of different camera systems, and that's what I have. I know I talk really, really fast. So questions?
Sandy, thank you so much. That was super informative. We have a question that came in a little bit towards the beginning of your presentation. And they were wanting to know, what was the figure 8 tube count configuration for?
Yeah, okay, I'll flip back to that real quick. So that figure 8 or that flip flop or crisscross, whatever, it's because this is, if for any of you that are from Eastern Ohio, this is Zanesville State Route 60, Maple Avenue. If you've got a car coming on this lane and a car coming on this lane, you're going to get basically the equipment's going to get confused. So what happens is by them doing this little flip-flop or crisscross, you can basically separate these lanes into who's in this lane and who's in this lane based off of the fact that one of these you're hitting it from here, okay, and the other one, even though the vehicle is driving from here, it's going to read, because the tube is flip-flopped, it's going to read as if he's going from here to here. I don't know if I explained that well, but it's so that you can get 2 lanes and they're going, you have to do some manipulation when you process this count, but yeah. Okay, any other questions?
That makes a great deal of sense. Thank you, Sandy. Our next question is, can we count Amish buggies?
On the shruggy?
Amish buggies.
Oh, Amish buggies.
Sorry about that.
That is something I've been talking to one of the, we could train a camera count to do it. It's machine learning. If you give them enough images and train it and say, this is a buggy, and we could put that into what we call our bin 15. So we count 13 classifications. We could assign bin 14 and bin 15 to be anything weird. Some of the counters say 14 is where they put their errors. Some of them say 15 is where their errors are. But we can assign those bins to be whatever. So through machine learning, we would be able to do that. We don't have anybody that does that right now. If you need a specific buggy count, we do have a couple contractors that still manually watch their video in high speed and break things down. So we do have that ability because we've done that with a couple special buggy projects that I think District 3 may have been the lead on. Yeah. Okay, next question. It'd be easy with machine learning and video counts.
Very cool. Next question. Where can that District 6 item 55 be found?
It literally just says on their big scope form, it says traffic monitoring count locations. That's all it says. And it's just their scope form is just, you know, I don't know how many numbers there are, but District 6 on their pavement scope form, they have all these items, and it literally just says tech services, traffic monitoring, count locations. And so it's almost just like a reminder to see if they need to talk to us.
Awesome. Thank you. Let's see here. Okay, there we go. Sorry about that. I wasn't getting the whole question. Where is the best place to find ODOT's count data? Would it be TIMS, MS2, lots of different options, all of the above? And then a follow-up question, is this the same data just in several different spots?
Okay, that's actually a really good question. Thank you for the segue to part 2. So we push our AADT data once a year to TIMS. So it is pushed from us. So it is the same data, but we only push our AADT, average annual daily traffic. So if that's all you want, TIMS is a wonderful location, and it should match with our data because we're pushing it to them. If you want more detailed data, you're going to have to go into the MS2 system. There are links from TIMS into the MS2 system if it is not a you're going into part 2. But anyway, TIMS is great if all you want is an average annual daily traffic. If you want more refined, more granular data than that, then you're going to have to go into the MS2 system. And the reason being, if we push all that granularity into TIMS, it would be too much in there and it would dramatically slow down the TIM system, and we don't want to do that. But we do want to make sure that we've got the data in TIMS. So it should be the same data, but we only push once a year into TIMS, and MS2 is updated nightly.
Great answer. Thank you for that. Okay. And what currently is our last question. So if anyone else has questions, go ahead and send them in quick. Oh, the person who asked that question said thank you.
You're welcome.
And let's see here. So we have someone who says, I am our ODOT district speed zone coordinator. And the fact that you get speed data, the 85th percentile speed, and the 10-mile-per-hour pace is immensely helpful. Thank you. So, not so much a question, but some
Yep.
accolades.
So a item to know if you're an ODOT person from the district is you can request us to take additional counts if you need them for a study or for a corridor or for something along those lines. We don't open that to everybody. If you have locals that need that data and you feel that it is a majorly significant to the state, we let the districts be that kind of filter for that. You're more localized, you know the actual details, you know the situation. We obviously cover the whole state. We don't know the whole state to the level that the districts do, so we rely on the districts for that expertise. But our contracts that we use for traffic counting is also available to the locals. So they can reach out to our vendors and get counts as well through our vendors if they want. And then the vendors will send them the counts, but they also send that to us and we push it to MS2. So that way we get the counts too, and everyone can use them. So
That's awesome. Thank you, Sandy. Okay, well, and we got another thank you from one of our attendees. So I will just say that we are all done with questions for today. On behalf of LTAP and ODOT, I'd like to thank Sandy Mapel for once again for sharing her valuable knowledge and expertise with us. As mentioned earlier, the recording of this webinar will be shared with all registered attendees. Thank you for attending, and we hope you found this webinar informative and engaging. Have a wonderful rest of your day.
thanks.